Hello grade 12s. In this video, I'm still going to be applying or using the table of standard reduction potentials, but I'm going to specifically be looking at question 2.3 because I found that this question was a challenging question for a lot of learners. So they say there are equal volumes of the following three solutions in three separate beakers. So we have magnesium sulfate, copper sulfate, and lead nitrate in solution. And they say that three electrodes, a magnesium, copper, and iron electrode, are placed in each beaker. So basically, we are just putting like sticks or flat sheets of each of these into the solutions. That's what we are doing, and we want to see if a reaction will take place or not. They tell us that in the beginning, the magnesium sulfate solution is clear, the copper sulfate solution is blue, and the lead nitrate solution is clear. And then in question 2.3, they say, in which beaker will a color change occur? Describe and explain the color change. Okay, grade 12s, copper in solution, the copper ions, copper 2 plus ions, tend to be blue. So if ever we have blue going on, I want you to think of these copper 2 plus ions, and you want to see if they go from being in solution to becoming a solid or going from solid into solution. Normally that's where this color change is going to take place. So what is happening is we need to analyze the reactions, the possible reactions that can take place in each beaker. We can start off with the one on the left and put a magnesium electrode inside of here. So this is made up of magnesium. We're putting magnesium solid in magnesium sulfate. Magnesium sulfate is basically just magnesium, 2 plus ions, and sulfate ions floating around in solution. When we put the magnesium solid into the magnesium sulfate, notice that nothing is going to happen because, well, magnesium is not going to replace magnesium. So we don't even care about that reaction. No color change is going to take place because, well, we're wasting our time. Okay, so the first one, we know there's no color change. Let's go on to the second one. Instead of using magnesium, we're now going to go and use copper solid. So we're now going to use copper, and we're going to have copper plus magnesium sulfate in solution. When this happens, we can force, or it may happen spontaneously, that the copper solid will become an ion, and the magnesium will go from being an ion, be reduced, and form magnesium solid. So let's go and take a look at these two reactions. We're dealing with magnesium and copper. So I want to go back up to this table. Here's my copper and here's my magnesium. What we are saying is our copper solid is going to go and form copper ions, so that's the product, and our magnesium ions are going to go and form magnesium solid. That is what we're saying is going to happen. So our two products are copper ions and magnesium solid. Look, copper ions and magnesium solid. Those are our two products. Now, you might remember in the previous video, I told you that in order to see if a reaction is spontaneous or not, we identify the products and then draw a straight line between them. We then see if we have a negative or positive gradient. And you guys see that this gradient is negative. That means that this reaction will not take place unless we go and connect some source of power to drive the reaction. It's not going to take place at all. So basically what that means is that our copper is not going to go and form ions. Okay, so no color change is going to take place in terms of the copper here. The next reaction that they talk about involves adding a lead electrode, Pb. So Pb solid is this electrode now, and we want to see if it's going to react. So we have Pb solid reacts with the magnesium ions to form magnesium solid and lead. Again, we would like to see if this reaction will happen spontaneously. So magnesium solid and lead ions will be our products. We've already highlighted the magnesium half reaction. Now we need to look for the lead half reaction. There it is. Remember, our products are lead ions and magnesium solid. Again, can you see we have a negative gradient? That means that this reaction will not take place spontaneously. We need something to drive the reaction. And since we don't have anything driving the reaction, this is just not going to happen. Okay, now the next one says we are dealing with the copper sulfate solution. So first off, let's start off by saying nothing is going to happen here. It's going to stay clear no matter which electrode you place into the solution, because no reaction is going to take place spontaneously. Now for the next one, we can go and put the magnesium electrode inside, Mg, that one. And we have magnesium solid and copper sulfate ions are going to form copper solid and magnesium sulfate. So the magnesium becomes ionic and the copper becomes solid. So we're looking for copper and magnesium. I think when you just read this problem, you wouldn't think that it would take so much, but yeah, it actually does. So there's my copper. We need to find magnesium again. There it is. My products are, okay, I've chosen the wrong copper. My apologies. We're looking for the copper that actually becomes copper solid. So we are looking for this one. There you go. All right. So my products are going to be copper solid and magnesium ions. Positive gradient. So what does that mean? It means that the reaction will take place spontaneously. That's what it means. This will happen on its own. And since my copper goes from being in ionic form to solid form, what is happening is that the blue is going to start to disappear. So in which beaker will a color change occur? Definitely we're going to have a color change occurring in beaker number 2, the one that has the copper sulfate ions. The second reaction, where you put the copper electrode in, nothing's going to happen. And then with the lead electrode, you are going to find again, so if we go up, lead electrode, we are going to end up, okay, so it is over there. When you put a lead electrode in, you're going to end up with copper solid and lead ions. Again, we have a positive gradient, a spontaneous reaction. So even over here, we know that the reaction will lead to these these copper ions being displaced out of the solution. So there we're going to have a color change. So definitely over here, we are definitely having a color change. All right. So in order to see if we're going to have any color change here, you're going to have to analyze this. And of course, your focus is where we have copper, because we know once copper becomes an ion, we're going to have a color change. I'm going to leave that up to you, but you should more or less see how question 2.3 can be answered. We are literally checking to see if reactions are spontaneous or not, and if the one color, the one thing that is blue, the copper ions, if they will be displaced out of solution and become solids. I hope that you've learned everything that you needed to in order to answer the rest of this problem. Guys, if you have any problems, you let me know and I'll assist as far as I possibly can.